Welcome to the start of our journey through the AWS metropolis. This presentation serves as your primary study guide for Domain 3, Cloud Technology and Services. This specific domain is the highest-weighted section of the AWS Certified Cloud Practitioner exam, accounting for a substantial 34% of your total score. To succeed, you must move beyond just memorizing names. You need an in-depth understanding of core AWS services and the global infrastructure that makes them possible. Think of this domain as the master blueprint for a modern, digital city. Just as an architect must understand the land, the materials, and the utilities required to build a skyscraper, a cloud practitioner must understand how AWS resources fit together to create a reliable and efficient system. Over the next 12 slides, we will construct our city from the ground up, starting with the land itself and ending with the advanced monitoring systems that keep our metropolis running smoothly. Mastering this blueprint is the most effective way to ensure you are prepared for the bulk of your certification exam questions. Every great city starts with choosing the right land, and for AWS, that land is its global infrastructure. This is the resilient, highly distributed physical foundation upon which every cloud service is built. This infrastructure is specifically designed to ensure high availability and fault tolerance for your applications. It is divided into 3 distinct layers: regions, availability zones, AZs, and edge locations. Regions, the continents. These are geographic locations spread across the world that are physically isolated from one another. To ensure maximum stability, each region is designed to be completely independent regarding its power and water supply. When you choose a region, you are choosing an independent foundation for your digital city. Availability zones, AZs, the city districts. Each region contains multiple AZs, which act as isolated partitions of the infrastructure. An AZ is comprised of one or more discrete data centers that feature redundant power, networking, and connectivity. By building your services across multiple AZs, you ensure that if one district has an issue, your city stays online. Edge locations, the local hubs. These are specialized data centers located in major cities globally. Their purpose is to bring services closer to end users to reduce latency. They are primarily utilized by Amazon CloudFront to cache content and deliver data with lightning speed. In our city analogy, the global infrastructure represents the physical land and the power grids that keep everything powered. Once the land is surveyed, the architect needs the right tools to begin construction. AWS provides 3 primary interfaces for designing, deploying, and managing your cloud metropolis. Each tool offers a different level of control and automation. AWS Management Console, the on-site visit. This is a user-friendly, web-based graphical user interface, GUI. It is the perfect tool for manually launching and configuring resources. Think of this as the architect walking the construction site and directing the workers by hand. AWS Command Line Interface, CLI, the remote directive. This tool allows you to interact with AWS services via single or multi-line commands in a shell environment. It provides a non-visual way to automate tasks, much like sending precise, written instructions to your build team from a remote office. Software Development Kits, SDKs, the automated blueprint. These provide programming language-specific APIs that allow your application code to interact with AWS services programmatically. Using an SDK is the equivalent of creating a self-executing blueprint where your application builds its own necessary infrastructure as it runs. These interfaces are your primary methods of communication with the cloud metropolis, similar to how a citizen might call the city council or send a digital service request. A city is just an empty collection of buildings until it has a workforce to keep it running. In the AWS metropolis, compute services provide the processing power for your applications. These services range from virtual machines that offer total control to serverless options that handle everything for you. When selecting your workforce, you must match the job to the worker. Do you need a dedicated, long-term employee who is always present? Or do you need a specialized contractor who only shows up to perform a specific, quick task? According to the sources, the architect's main goal here is to decide if they need full control and persistent presence or just a quick task completed with maximum efficiency. In our analogy, compute is the active workforce of the city. Your Amazon EC2 instances act like regular, full-time employees, while your AWS Lambda functions are more like contractors hired only for specific, 15-minute tasks. Let's take a closer look at the three main types of workers you can hire for your AWS Metropolis. Amazon EC2, the salaried employee. This stands for Elastic Compute Cloud and provides secure, resizable compute capacity through virtual machine instances. With EC2, you have full control over the operating system and the software configuration. This is exactly like hiring a full-time, salaried employee. You manage them directly, but they can perform almost any job you assign. AWS Lambda, the gig worker. This is a serverless compute service. It runs your code in response to specific events without requiring you to provision or manage any underlying servers. Think of Lambda as a contractor hired for a single, specific task. They show up, do the job, and leave immediately. You only pay for the exact time they are working. Containers, ECS, EKS, and Fargate, the prefabricated team for those using Docker or Kubernetes. AWS offers Amazon ECS and Amazon EKS to orchestrate containerized applications. To make this even easier, AWS Fargate acts as a serverless engine that runs these containers without you having to manage EC2 instances. This is like deploying a fully equipped, self-contained specialist team that arrives ready to work with all their tools already packed in a crate. Now that our city has a workforce, we need a place to store our materials. Every thriving metropolis needs robust and diverse storage solutions. AWS provides a place for every piece of data, whether it's a file you need to access instantly or a record you need to archive for a decade. Phase 3 of our blueprint focuses on core storage services. Choosing the right storage is one of the most fundamental architectural decisions you will make. The sources explain that AWS provides various storage types based on your specific data use cases. We categorize these based on how the data is accessed: object storage for massive scale, block storage for high performance, file storage for shared access, and archival storage for long-term retention. In our city analogy, storage options range from your office filing cabinet, EBS, to a massive warehouse, S3, or even an off-site underground vault, Glacier. Let's break down the specific storage facilities available in your blueprint. Amazon S3, the massive public warehouse simple storage service, is an object storage service. Data is stored in containers called buckets. S3 is designed for extreme durability, 99.999999999%, often called 11 nines. It is ideal for storing vast amounts of data like images, videos, and backups. Amazon EBS, the private office safe elastic block store, provides block-level storage volumes. These act like virtual hard drives for your Amazon EC2 instances. This is your server's local, high-performance storage that stays attached to that specific worker. Amazon EFS, the shared corporate drive elastic file system, is a scalable, managed network file system. Unlike EBS, EFS can be shared and accessed by multiple EC2 instances simultaneously, just like a shared network drive in a physical office. S3 Glacier Deep Archive, the underground vault. This is the lowest cost storage class in AWS. It is used for long-term archival data that you rarely need to see. Be aware that retrieving this data can take 12 hours or more. Data is the lifeblood of our city, and as it grows, we need specialized ways to organize it. AWS provides several database services to handle everything from structured records to high-speed transactions. Amazon RDS, the public library, the relational database service, is a managed service that automates relational database tasks for engines like MySQL and Amazon Aurora. It is perfect for structured data with clear relationships, much like a library's card catalog where every book is linked to an author and a genre. Amazon DynamoDB, the high-speed document courier. This is a fully managed NoSQL database. It is designed for low-latency performance even at massive scales. It is ideal for applications that need fast, flexible access to data, similar to a real-time courier tracking system. Amazon Redshift, the central analytics department. When your city needs to perform complex analysis on petabytes of data, you use Redshift. It is a data warehouse optimized for online analytical processing, OLAP. Cities use this to understand citywide trends and perform complex business intelligence queries. A city is only as efficient as its transportation and communication networks. These services control how your resources connect and how citizens, your users, access your services. In our city analogy, networking represents the system of roads and highways that allows everyone to move and communicate. Amazon VPC, the Private City Limits Virtual Private Cloud, allows you to provision a logically isolated section of the AWS cloud. Here, you define your own virtual network, creating a private, secure space for your resources. This is exactly like defining your city's boundaries and its internal road layout. Amazon Route 53, the city's address system. This is a highly available and scalable cloud domain name system, DNS. It translates human-readable names, like www.mycity.com, into numeric IP addresses. Think of it as the city's official, global address book. AWS Direct Connect, the private superhighway. If you need a dedicated line from your on-premise data center to AWS, you use Direct Connect. It bypasses the public internet, acting as a private, high-speed highway straight into your city. A modern metropolis requires sophisticated tools for automated construction, continuous inspection, and operational oversight. These tools ensure that your city is built to the correct specifications and runs smoothly every day. Infrastructure as code, AWS CloudFormation. The automated construction crew's CloudFormation uses templates, JSON, or YAML to automate the provisioning of your infrastructure. You write the plan, and CloudFormation builds the city for you, ensuring every building is exactly where it should be. Real-time guidance, AWS Trusted Advisor. The City Inspector. This is an automated tool that provides guidance to help you follow AWS best practices. It acts as a specialized inspector that looks at 5 critical areas: cost optimization, performance, security, fault tolerance, and service limits. Observability, AWS CloudWatch. The central surveillance system. CloudWatch is a monitoring service that tracks metrics, logs, and events across all your resources. It is the city's central nervous system, telling you exactly what is happening in your metropolis at all times. To manage a complex city, the architect needs more than just a camera. They need a central operational command. This slide dives deeper into the tools that provide governance and oversight for your metropolis. As we mentioned, AWS CloudFormation is your master blueprint. For those who prefer using familiar programming languages instead of JSON or YAML, AWS also offers the AWS CDK, Cloud Development Kit, to generate these templates. AWS Trusted Advisor is your city inspector, constantly checking your buildings to see if you can save money on electricity cost optimization, or if your fire exits are clear, security. It provides real-time checks across those 5 critical pillars to ensure you aren't exceeding service limits or risking a collapse in fault tolerance. Finally, AWS CloudWatch is your central control tower. It doesn't just watch, it tracks metrics, the speed of traffic, logs the records of every door opening, and events, alerts if a fire starts. This observability ensures your environment is built to spec and runs efficiently, acting as the primary nervous system for your digital city. We have reached the end of our construction project. This final slide shows the complete blueprint of the AWS metropolis, where every service we have discussed works in harmony. Look at how the global infrastructure of regions and AZs forms the base of the entire diagram. You can see the VPC roads connecting our RDS libraries and DynamoDB couriers. Our EC2 and Lambda workforce is busy processing data, while our S3 and EBS warehouses keep our stuff safe. High above it all, the CloudWatch control tower monitors the traffic, while CloudFormation stands ready with the blueprints to build new districts at a moment's notice. By understanding this blueprint, you have mastered the core concepts of Domain 3. You now understand the land, the tools, the workers, and the utilities of the AWS cloud. This foundational knowledge is your key to passing the exam and building your own thriving digital metropolis.